Hi everyone, welcome to the 7th edition of Serverless Saturday. I am Smile and today I have Dharam with me. So we so we have lined up with amazing speakers. So Dharam, would you share your screen and will let's tell everybody who the speakers are.
Yeah. Hello, everyone. So I will be sharing the screen. Hope you're able to see.
Yes.
Yes. So welcome to the Serverless Saturdays 7th edition, and we have amazing session today, and we have few announcement to do. So I'll be doing the announcement. So first we have the announcement for AWS Community Day South Asia, which is virtual edition 2021, going to happen on this October 22nd and 23rd. And you can probably join this event and register for this event, and we will be sharing the link in the comment box. And after this I will introduce with you our first speaker. So we have Philip Peck from Purple Technology, and he is holding a position of serverless solution architect in the Purple Technology. So it's a fintech company, so we will be getting hands on like how the fintech world is using the serverless, and he will be sharing his journey. So we are thankful to Philip to join us today. And then we have our second speaker, who is Lalit Kale. He is uh, working in the Verizon Connect, and uh, he will be joining after the Philip session. So stay tuned with us for the exciting sessions. So, and I have one more announcement. So I will be just sharing my screen. So if you guys want to connect with us and contribute to the serverless Saturdays, so we have our GitHub repo also. So we will be sharing the link in the comments, so you can check it out. And if you want to contribute to our serverless, so you can contribute here. And this is our team. And if you want to uh, get in touch with us for the session uh, in this serverless Saturday, so you can contact with us as well. So over to you, Ismail.
So yeah, so that's pretty much we have for the day. So we'll add Philip to the stream now. So let's learn from him how serverless works in the fintech industry.
Hey guys.
Hi
Hey,
Philip,
Philip.
hope you are doing good.
Yeah, thank you for a warm welcome and invitation here.
Thank you so much for joining so early for Serverless Saturday.
Sure thing.
Yes, Philip. So maybe you can introduce yourself, and then we can go with the talk.
Yeah, I have an introduction in my presentation, so maybe we can keep it for that. Is this
Yeah,
okay with
Sure.
you?
Philip, you can share your screen and presentation.
Yeah, I'm sharing. Hopefully,
Okay. So we will add it to the stream.
perfect. All right. So may I start?
Yes.
Yes. No. Over to
Perfect.
you, Philip. Now.
All right. Uh, yeah. All right. Serverless at fintech industry. First, I will introduce myself. I'm a Filip. I'm an AWS certified AWS community builder. I'm a head of platform at Purple Technology and serverless architect and full stack TypeScript developer. If you would like to see more some tweets about serverless and what's new in serverless, what are our new solutions, definitely follow me on Twitter. And if you would like to see more links about me, definitely check out my all my links profile here through the QR code. Because I'm a big fan of 3D printing, from time to time I also print some AWS serverless themed stuff, like you can see on the images. I love Prusa printers, and I print some of these decorations. So if you like it, you can find it on my website and print it yourself, basically. And definitely, if you print it out, tag me on Twitter or LinkedIn. I will be more than happy to check that out. All right, something about Purple Technology. We are innovative fintech company based in Brno, in Czech Republic. We are one of the biggest serverless players in Central Europe, and we are building software for global trading brokerage companies, which have more than 1.2 billion US dollars in daily trading volume and more than 30,000 daily trades. More about Purple Technology you can find on the website mentioned down below. What is the history of our tech stack? First thing to mention is that what I'm going to talk about is so-called web tech team, because we have also a fintech team, which is really focusing on the trading itself, which is a chapter about itself. So I'm going to talk about the regulatory processes and stuff like that, just to give a disclosure. So what we were building these processes on top of was EC2, Node.js, CoffeeScript back then, also Ember, and everything was powered by REST APIs. For storage, we used MongoDB and MySQL, and yeah, slowly it got basically outdated. We used old versions and stuff like that. So we needed to figure out how to do a proper upgrade, and we came up with this. We came up with TypeScript. We used serverless framework for powering all that up. We used Lambda with Node.js runtime. Use GraphQL for building APIs. We started using MongoDB Atlas for having a managed MongoDB with a lot of nice features, and also Postgres as sort of a more mature relational database. Dynamodb for some, let's say, application slash temporary data, and React.js and Next.js for frontend. Mm. Finance industry is very regulated one. If clients want to do any action, they first must go through regulatory processes, and that basically means that as a fintech developers, we are essentially translating law into source code, and we need to do anti-money laundering checks. We need to do know your customer checks. We need to do many different approval processes and so on. And as the complexity was growing, we started to search for better solution, some tool which would give us better observability over the complex processes and ability to do changes to them during runtime. And I'm lucky to say that we found it. It's called AWS Step Functions, and it is all we were looking for. This was the first impulse why we went serverless at all. We were finally able to split those complex processes into individual Lambda functions, into so-called steps, and organize them into state machines. Here you can see example of a state machine, like the biggest one we have right now. This one is part of onboarding of user onboarding process. All those boxes are individual Lambda functions. We will go through that more later on. All of that was accomplished thanks to serverless framework. Back then, basically the only option on the market. And under active development ever since. Level of customizability is endless thanks to a huge and open plugin ecosystem. We have several plugins of ours. Some of them are private and some of them are public, so you can find them on our GitHub. And defining also, and it allows defining also non-Lambda CloudFormation resources. And this was quite important part for us because we were about to build huge applications, and we needed much more than just creating a Lambda function. We needed infrastructure as code. And because serverless framework is already powered by CloudFormation, we decided to use it. So we are defining DynamoDB tables, SNS topics, SQS queues, Cognito user pools, etc. in serverless YAML via CloudFormation notation. Now we will go through a list of services we use. Lambda is the main building block of every serverless infrastructure. It gives you ability to customize the behavior of managed services. We write the code in TypeScript, bundle it newly with ES build, and then deploy it to the Node.js runtime. Regarding the cold starts, it has no impact on our use case. By that I mean that we don't feel it anyhow. Nothing feels slow to us, so that's okay for us, for our use cases. And I'm proud to say that our bill is approximately 10 times lower than our former solution, which were Kubernetes clusters. DynamoDB is a key value slash document store database from AWS. Since DynamoDB querying capabilities are optimized for online transaction processing rather than online analytics processing, it's good for technical or temporary data used by application. Um, it has big advantage that it is supported by CloudFormation, which is super useful for serverless apps, and it has on-demand pricing where you pay per request, which is another super cool feature thanks to which your apps can be truly serverless. And because it supports Lambda triggers, you can create amazing workflows which are reacting on changes to the data in the table. For example, you have an eShop and you change status of order to shipped in the table, and the updated information is delivered to Lambda trigger, which then sends email to the client that the order has been shipped. What an amazing event-driven architecture, right? CloudWatch is a default monitoring and debugging tool from AWS. It is quite powerful, and you can handle quite a big workflows with it. CloudWatch Metrics is a browser of metrics which are provided not only by AWS services. You can view their stuff like number of invocations of a Lambda function, number of errors of Lambda function, average duration of the function, etc. You name it. CloudWatch alerts are built on top of CloudWatch metrics. You can set a threshold on a metric, and if the threshold is exceeded, alert is triggered and action is performed. So, for example, Lambda trigger. CloudWatch logs is a place where all the logs are stored from AWS services and aggregated. CloudWatch Insight is awesome new feature of CloudWatch logs which enables you to search through the structured logs using queries. For example, if your Lambda function is logging JSON strings, you can write a query which will search based on the nested values inside the JSON object, which is pretty useful. API Gateway is the easiest way how to make Lambda accessible from the internet. It supports REST APIs, HTTPS endpoints if you just want to create some endpoint which doesn't necessarily needs to be REST, or WebSockets in case you want to build a truly event-driven application. And all this can be hooked up to Lambda function, even the WebSockets. And API Gateway can be very powerful tool, but it can take some time to master it. Cognito is, for example, something like Auth0. It's a service which provides you authentication layer for your application. It's not the nicest of AWS products, but its native integration to other services balances out those disadvantages pretty much. Users can sign up, sign in, they can manage their multi-factor authentication, and many other things. Cognito also offers lifecycle activities like, for example, email verification messages after registration, etc., which can be all managed by Lambda triggers. So the customizability allowed by the triggers is unprecedented. And Cognito also supports federated sign-in, which means that your users can log in via Google, Amazon, Facebook, Apple, or others. CloudFormation is a native infrastructure tool of AWS. Uh, Infrastructure as code is a must-have for modern cloud application, basically. It makes infrastructure transparent and deterministic. It basically helps you to keep your cloud clean. Thanks to its features, thanks to its feature called custom resources, you can implement your own resources. Thanks to that, improve your deployment process. For example, we create our own custom resources for managing MongoDB, which is not natively supported by by CloudFormation. We manage to that databases, indexes, schemas inside the MongoDB. The YAML notation looks on the first sight ugly, and the JSON is even worse. But I strongly recommend you to give it a chance and try it out. AppSync is basically GraphQL alternative for API gateway. GraphQL is open source data query language from Facebook and is used for modern APIs. Important thing to know about AppSync is that it doesn't support unauthenticated API access. That means that every request must contain some token or API key. There is no option for making a plain request without authentication. I'm not sure why is it so, but it's one of the main architectural principles of AppSync. It has direct integration with several AWS services. The default data source is Lambda, but it supports also Dynamodb, RDS, and others. From the application development perspective, it's nice that AppSync has easy native integration with Cognito. Just a few clicks or lines. That means that users can log in through Cognito SDK and then send the request to AppSync API with the token they received from the Cognito. S3 is well-known and battle-tested object storage created by Amazon back then. It also is also well supported by CloudFormation, which means that it can be easily integrated to your serverless apps. And excuse me. And it also supports bunch of Lambda triggers, which allows you to create beautiful event-driven applications. And our lovely step functions are here. I would say that they are key ingredient for achieving long-running processes in serverless architecture. Organizing Lambda functions into state machine increases their overall added value. It enables developers to decouple infrastructure logic into multiple steps, and more on that later. Cloudfront is a content delivery network from AWS. Aside from the
Hey
CDN,
Philip,
yeah,
sorry to interrupt. You are not audible. Actually, your voice is coming low. Could you please adjust the microphone?
sorry, I don't understand.
Actually, you aren't audible properly. Can
Yeah,
you
this
move
one.
closer to the mic?
Is this better?
Yeah, yeah,
Yeah,
this is
sure.
good.
Thank you
Okay,
for letting me know.
just continue. Sorry for interrupting.
Cloudfront is a content delivery network from AWS. Aside from the CDN aspect of Cloudfront, is very good tool for getting an HTTPS address of your application. In combination with AWS Certificate Manager, you can generate whatever SSL certificate you want for your domains and subdomains, even for wildcards. We use it, for example, for serving statically generated front end from S3 website hosting. It has two interesting features: CloudFront functions and Lambda at Edge. Oh, excuse me. Those two features have a bit different parameters, but essentially they allow you to modify the requests or responses of the origin request or the view request to a Lambda function. We use it, for example, for keeping query parameters for S3/redirects because S3 is dropping those by default. So we need to return it back. Eventbridge is basically an event bus through which you should populate all your backend events. You can then hook up a Lambda function to react to some particular event happening in the system. It's something very small and not that much visible, but it's a key element for building event-driven applications. It also has integration to third-party software as a service services like Salesforce, Auth0, Datadog, Abstragon, MongoDB, and so on. SNS or Simple Notification Service is a pub sub service like, for example, Kafka. It can handle many different locations, but in case of serverless, it's mostly used for delivering the same payload to multiple Lambda functions. The use cases can be quite similar to Eventbridge, and we can say that SNS is sort of a predecessor of Eventbridge in terms of serverless apps development. But the main difference between SNS and Eventbridge is pricing, so make sure to choose the right tool for the job. If I'm not mistaken, according to my calculations, Eventbridge is 2 times more expensive than SNS. In case of some user information update events, it might be okay, but in cases like pricing changes of dozens of symbols every second, it can get expensive. SQS or simple queue service is a queue service like, for example, RabbitMQ. SQS is good for use cases when your Lambda function is communicating with non-serverless infrastructure, which can scale indefinitely. For example, some RDS database or third-party API. But for most serverless use cases, it won't be necessary since all serverless services have no problem with scaling. And also, the integration between Lambda and SQS can have its issues, and it's not so smooth. After several iterations of serverless apps development, we decided 2 years ago to create our own dev stack, which we will then use for building our new apps. The reason for that was that there was not anything like it on the market, which would fully fill our needs. And as far as I know, there is still no proper alternative. We set four main points we needed the solution to comply with. It was monorepo, infrastructure as code, CI/CD, and the last one, of course, serverless. Uh, Monorepo we chose because we tried polyrepo before and it didn't work well for us. And because the application was spread around multiple repositories and it was hard for developers to orient in. Infrastructure as code is already for quite some time cloud best practice, and because it makes the whole infrastructure much more manageable and transparent. That's why we chose it. And in the CI/CD, by that I mean mainly the unit test checks in GitHub, feature deployments, also end-to-end tests and stuff like that. To give you a perspective, what we achieved with such a dev stack, our currently biggest monorepo, one monorepo, has more than 140,000 lines of TypeScript code, more than 10,000 lines of serverless YAML configurations, 400 Lambda functions per deployment, 25 state machines, 20 Dynamodb tables, and it is still growing. And I'm not counting the RDS databases and stuff like that. I'm purely talking about the serverless stuff. The dev stack is open source, but it's far from having developer experience like, for example, Amplify, because we don't have enough resources to implement. There are things that others might use, but we don't use them. On the other hand, it can serve you as a nice inspiration on how to solve different problems. And trust me, we solved a lot of problems and challenges. So you can check it through the QR code or the GitHub link. Now let's take a look at some examples from the purple stack. Uh, so the first one is the configuration part where we extracted the whole repo configuration to the serverless settings YAML file. Um, you can set the project name, region, define the runtime, of course, the deployment bucket, log retention, function versioning. Also, the CI/CD configuration is here, the role under which the CI will deploy your code. You can also set the VPC configuration, which is usually necessary for bigger applications. And also, here is the monitoring, which uses AWS chatbots for getting alerts into Slack. And then we can configure also our front end and where we choose to which domain we want it to get deployed. And also we choose the SSL certificate. Uh, the whole documentation about like how to set up the serverless YAML file is on the GitHub of the purple stack. Here is a setup tutorial where you see serverless settings, you see CI, and also explanations of the libraries you use there. All right, here is the project structure. The project is made of API, backend, front end, and also packages, which are individual local packages used across the repository. We have a package for managing secrets, we have package for logging, for configuration, for environment variables, and stuff like that. if you go through API, we can see the serverless YAML configuration. We are using special plugin we created for deriving deriving serverless stage from the Git branch.
Hey Philip,
All right. Yes.
actually the text is not visible properly. Could you please increase the size of this workspace?
Not really because it is a video, so unfortunately I will not be able to do that. Is it really that of a problem?
No problem, no problem. Uh,
Yeah, sorry for that.
okay, all right.
Hopefully it will be better on YouTube with the higher resolution. And yeah, here is a generator which basically creates functions list based on the file structure here in the GraphQL folder, where are all the upsync resolvers defined. Excuse me. And yeah, we're also using AppSync Simulator for developing the local API. And yeah, let's take a look at the scripts. Yeah, here we have also deploy, package, remove, info scripts, which are used for the lifecycle of the application, and also the local development script, which is using serverless offline. Yeah, here are being defined the GraphQL schemas. Basically, it will combine all these files into one schema in the end. And here you can see some types being defined and the query mutation. All right, let's take a look at the source code. Here we are using a package called GraphQL types, uh, which are generated TypeScript types according to GraphQL schema. So if we take a look at the types, you can see like mutations, queries. Excuse me. Sorry. Here you can see the GraphQL code again. That's the CLI tool which is responsible for generating these types. And yeah, here we can see mutation. Let's take a look at the schema. And yeah, the mutation is here. You can see the individual fields in there. And then we use it in the code. We are using AWS Lambda types. And here we use AppSync batch resolver handler, where we provide these types. And this grants us that if we do any changes to the schema, we must run the GraphQL code again in the CI, and then we will get notification that, hey, you changed the schema, but the types are not fitting your application. You should fix your application according to the schema in order for it to work properly. All right, let's move to the next one. Next one are resources, which is also a building block of the whole application. Uh, Basically, here are defined only CloudFormation resources, no functions, basically. And these are resources which are then being used across the whole application. Basically, we can say that those are shared resources across the application. Important part of the resources or all the stacks essentially is outputs. These outputs are then used for uh, creating relationships between individual stacks through CloudFormation imports. Basically, you can see the service name here is the project name dash resource, and here we use the import value, which is project name dash resource, and then follows up the stage and then the name of the import. So to do stable name or to do stable ARN and stuff like that. All right, so here are the resources. Again, the same scripts for packaging, deploying, and info, or eventually running the local server. And also there are some tests in certain cases. All right, let's move to the next one. Uh, Next one, we move to backend service itself. Here you can see we have service name defined. It is called add to do. Here is one simple function add, which basically writes to the Dynamodb table. It has some input. Here you can see the types and the input validators. And also some unit tests. We try to do unit tests everywhere. Here you can see state machine definition. It is very simple one. In this case, it is just one step, and it's just for demonstration. And you can see the reference to the add function here, to the get attributes intrinsic function of the CloudFormation. And again, we export the state machine ARN for it being imported in API later on. Yeah, let's try to run some unit tests now on the backend. We are using Jest for that, and it's integrated in each service. So let's run it through. Yeah, it was successful, 100% coverage. Perfect. Let's move on. And now we come to frontend, where we are using Next.js in combination with serverless framework. We are using serverless Finch plugin, which does upload to the S3 bucket, which is then created down there. We'll get to that. Yeah, here is being created, the serverless bucket, and then Cloudfront distribution for distributing the front end in order to make it faster and also to get the proper domain name. And here we connect it to the domain name itself. If we go to package.json, we can see all the scripts here. And here is the next configuration. You can see that we are passing there these environment variables, which are, for example, referencing API URL, API key in order to create the relationships and connect the front end to the API in the end. And yeah, we are running this load deployment and variables script before they build and export, which basically gets the information from the API or in frontend or other backend services and loads them to frontend. Yeah, in the end, it's basically the Next.js. We are using Amplify there. That's important thing to say. We are using Amplify libraries, which I would say they are really good, and I can strongly recommend them for interacting with AWS services. And we are also using styled components for styling all the front end or front end basically. And we are using Internationalization Api for React. So here you can see it. We are using like translate main title, and that means purple app. Yeah. Yeah, we are using special around construct basically, which is using context providers, which is called models. We have this feature called Modalify, which basically wraps the body of the model into a context provider basically, and yeah, it handles all the types, all the type safety of the TypeScript, and here we can see it being used. You can see the individual functions of the model. You can see here like fetch to do's, add to do, remove to do, switch, check, and all that stuff. And for all that, we are also using generated GraphQL types. And here on the index, we can see it being used. We have this use model hook, which just basically makes sure the data is provided to the model from the parent company, parent component, sorry. And here you can see it everything being typed properly. We really love to set up the TypeScript properly, I would say. Yeah, here you cannot forget to make a context provider when you are doing a context-based models. Yeah, here we are using Amplify again for calling the API. It's api.graphql. Again, I can more than recommend it. All right, next one is let's take a look at the deployment. Let's deploy the resources first because they need to be deployed because other applications are dependent on them. This is everything being also handled in CI, but we will take a look at the manual configuration. CI automatically filters out the packages and by the dependency level and creates them. All right, here we are taking a look at the cloud formation. We can see that the table table creation is in progress. All right, we need to wait a bit because it takes time, cloud formation, to handle all that stuff. Yeah, that's also a disadvantage of the deployment sometimes, that it takes time. Yeah, finally it's done. And here we can see the service information output. And if we take a look at the npm run info, we can see what we get as an output there, which is then being used on the front end as we saw before. You can see stack outputs. You have these to-do table ARN. And if you take a look at the output here, serverless YAML, down there, and to-do table name, to-do table ARN. Here we can see them. Yeah, those are they. Yeah, let's deploy the add to-do service. The process is basically the same. Thanks to serverless framework, making it, let's say, unified. That's another good thing on serverless framework, making a unified interface basically. Yeah, here we use Webpacket. All right, it's getting deployed. Uploading the zip file, creating stack. Yeah, it does the loading. Let's move it a bit. Loading. Yeah, here we are. Lambda functions are being created. It's in progress, as we can see. Create in progress of state machine role. I will fasten it up. Let's go. Let's move it up. Let's fast forward. Yeah, it's created. Perfect. So again, if we run npm run info, you can see the outputs here. Here's add to the state machine. Oh, no, wrong folder. Here we are. Add to the state machine. Yeah, here it is. Yeah, you can see the output, the export name. Now let's deploy API. again, npm run deploy, same for all the services. It essentially runs serverless deploy. Here we can see the dependency that add to do is being imported here. So that's why we had to create it first. Again, a lot of webpack packing. I will fast forward it. Yeah, deploying. Yeah, refresh. API is being created. Here is a lot of resources which are being created, so I will fast forward it because it takes time. Yeah, create in progress. In progress. Yeah, a lot of loading. You can see a bunch of resources being created there. Really a lot of resources for such a small API, right? Yeah, creation still in progress. Let's go, let's go. Yeah, stack creation finished. Perfect. So we refresh and create complete. npm run info, and here we go. We have GraphQL API key, GraphQL API URL, and the bucket name. So those are the things we saw that we imported on front end here in the script folder. No, scripts, yeah, here. Uh, you can see this. It's exactly matching, yeah, and then it will parse the value which comes out of this key. Also, it parses a region. You can see it from the output there. Yeah. Let's take a look at what the resources were actually created. Here we can see the to-dos table. Let's take a look at that one in the new DynamoDB console. You can see here all the information, all the monitoring capacities and stuff. Yeah, let's take a look at the items. We can see there are no items right now in the table, obviously because it was just created, right? Here we can see the add to do state machine. Again, it's going to be empty because no execution has been created yet, right? Here we can see the definition, JSON. We can see that it's really simple. It's just one step, which is this Lambda function. And the final one, or not yet, but it will be. All right, yeah. Lambda function. Yeah, here we can see the Webpack code, Webpack transpilation, and yeah, the last one is API. A lot of his resources here, the different like app sync constructs. Let's take a look at AppSync. It is really nice console, and here we can see the whole schema. Here we can see the resolvers being attached to the individual APIs, and let's do some queries. Uh, let's take a look at what to-dos it has to offer for us, and run it. And there are no to-dos, right? Because the database was empty. So let's create some. Hello. All right, success. Let's take a look at the database if it's there. Let's view items, and yeah, it's here. You can see hello. Nice. And let's check that. Let's check the to do. Let's add mutation, switch check. We need to get like the ID, which is the timestamp when it was created, and we can run it. Again, success. Let's take a look at the Dynamodb table. We can see it's false, and if we refresh it, it is switched to true. Now let's load the to-dos and we can see it here. Perfect. Yeah, here we can see some settings of the API. You can set the API keys and stuff like that. And also monitoring is here. And let's take a look at the state machine. Here we can see the execution was created. We can see the history, and we can see here the input, which was the hello. Here we can see the progress of the whole execution. We can view the logs of the Lambda function here. Yeah, and here there are no logs basically. So here we can see just the start and the statistics about the execution, like the memory and the duration and stuff like that. And now we will trigger the deployment of the front end. Mm, which basically creates the distribution and the S3 bucket, which we will then upload the contents into. And here the Lerna is being locked out because it's doing the loading of the API keys of the API URL and stuff like that. And now the Next.js is building the final application basically. Yeah, now the Next.js generates. I will fast forward it, and now it's uploading to the bucket. Yeah, and it's uploaded. Now let's take a look at the front end demo. We can see here the distribution is created. We can see the bucket. We can see the DNS records. So let's take a look at the distribution, and here we can see again the settings, the origins, behaviors, all that which can be set. And here we will try out the application, and we see our hello here. We created through API before. We will say hi, and because it's example through state machines, it takes some time. It's not a good example actually to do, but we had no other idea how to demonstrate it. And here we can see we are doing the actions, and here we go. This is our deployed front end. It's on this address. Yeah, hello. Hi again. Yeah, and it's there. We can check the tables that it's really being created there. Here we can see the record. Hi again. And we will enable it, and it's again it's false, and now it's true. Yeah, let's continue. Now a quick intro how we work with step functions. One important aspect for us is making sure the errors have no fatal impact on the overall execution. By that I mean that if the last step of a state machine fails, we can't afford it to take down the whole state machine. We want that error to fall into a catch block where it stays until some human starts debugging and eventually restarts the step, which then successfully finishes the state machine. The other use case is asynchronous activities. Quite often in our industry, we need continuation of some process to be reviewed and approved by a human. And for this, we created a step which waits until somebody approves it, and then execution continues. Uh, we also use this for asynchronous input from third-party systems. Sorry. For example, we are using services for validating IDs or passports. And when we submit the images to the service, we need to wait some time until it processes them, and either through some AI or humans. So we need to wait. And let's take a look at examples. Error recoveries. Here we can see the steps which have their recovery steps. You can see it here. The circle, basically, the cross reference between the two steps. And there is a condition that if the main step fails, the catch block redirects the flow into the recovery step, which is waiting for a developer to trigger an action. Developer can, for example, deploy a hotfix and then approve it. and the repetition and approve the repetition of the previous step. We achieve this via a feature of a step functions called wait for task token here. Uh, and this is the way we receive as a part of the input event also so-called task token, which we can then use for AWS API call via SDK, where we submit a task success, which causes a state machine to continue, as you can see on the documentation on the right side. We created a special Slack bot for recoveries, which is used by our maintenance team. Every time a step fails and enters the recovery stage, we receive a notification. We can see there all the details and eventually open the execution in the browser through the link. After fixing the problem, engineer can either click on run again to repeat the previous step and continue in the state machine execution, or he can click reject, which causes the whole state machine execution to end up in an error state. With async activities, the technical solution is basically the same, except that we call it, instead of recovery, we call it wait for. And yeah, it's just waiting for something from outside to happen. And what I see the next steps for serverless. After more than 4 years of active experience with serverless, I'm thinking a lot about what is missing in serverless ecosystem and what the next steps should be based on our operations needs. One thing which could make developers' lives easier is something like hot reload used in Webpack, because it's hard to do one-to-one local replica of cloud environment. The recommended way of debugging serverless apps in the cloud, um, uh, but but deploying application can take a lot of time. One thing is compilation of the source code, but the other thing is delays caused by cloud formation. As far as I know, serverless tech framework, for example, is already trying to tackle that and that problem, and so hopefully all framework will get inspired by that. Next thing which would make developers' lives easier is tool for creating a simple UI controls for serverless apps. Serverless is also about focusing on the added value for the business and outsourcing the common logic to the cloud provider. When developers develop an application, they need also some sort of back office or administration for it, and creating administration is also very time intensive and also a very big demand on security. But I believe that it should be possible to create a platform where developers could create UI elements like buttons, inputs, and stuff like that, which would then be hooked up to Lambda functions. This would accelerate the serverless adoption even more. And the last thing is that comes to my mind is tighter interconnection between infrastructure definition and application source code. Because, for example, in our case, we use TypeScript, and if we want to have our code base type safe, we can handle it up to a certain limit. And that limit is the interface between Lambda source code and the CloudFormation template. And this could be eliminated by tools like AWS Cloud Development Kit. Here's an example. Because CDK you write your infrastructure definition in TypeScript, and if you write also your application in TypeScript, you can then share some types and configurations between both infrastructure and application, which helps you to tighten them up. If you like to learn more about how we do serverless and technology in general, you can find it on our blog, which is blog.purpletechnology.com. We are also hiring. So if you live in Czech Republic or you would like to move to Czech Republic, definitely check our job offers. We are looking for several serverless engineers. We are looking for senior full stack developers or newly for React Native developers. Thank you for your attention. Now we have space for Q&A. Hello, is anyone there? Hello, smile.
Yeah, sorry. So it was an interesting topic. So me being a front-end engineer, it was like I was very curious how things work in a fintech world. So I to loved your session.
Thank you.
So, guys, if you have any comments, any doubts for Philip, please put them in the chat section, and we'll happy to answer.
Yeah, was the audio okay on the start?
So it was a little low in the start,
I see.
but
Yeah, yeah.
it was
Hopefully it's going to be okay.
yes. So till the time people ask questions, so one question I have: how's it working in fintech? So how different you feel fintech is from other techs?
Sorry, how?
How fintech? How is it working in fintech? And how do you feel fintech is more better than, or how is it like how you came into fintech? You thought about you will work in fintech.
Yeah, how I came to fintech.
Yes.
Yes. Um, yeah, this is basically the first company I work for. Uh, I got there during high school, and yeah, because I like economics and I was interested back then a lot of in cryptocurrencies ecosystem. Basically, this was the best choice for me to join a fintech company because I really have it like a hobby, the economy, and this was the perfect match. Yeah.
Nice. So we have one question from Srishit. The question is, what about the security aspect of running lambdas in fintech world?
Yeah, since AWS services have a lot of different certifications. It always depends on the company which certification it needs. And in our case, AWS have everything we need from it. And but important thing to say is that those services have many different certificates, but they are compliant with the certificates only under certain configuration. This was also a big lesson for us that we learned from the security experts that okay, they say it's compliant, but you need to configure it to be compliant.
So yeah, so I guess that's what we had for this talk. So thank you so much for
Thank
joining,
you.
and
Thank you for
especially
attending.
thank you for joining at 7 in the morning. So
Yeah, happy to do that. Thank you for your invitation again and warm welcome. Thank you.
yeah. Okay, so I'll share my screen for the next things. So this session is going to be very interesting. So one thing is that we have speakers. Lalit is one of the speakers who have been working as a software engineer from 16 years. Oh, so yeah. So basically, he's a principal engineer in Verizon Connect, and he have 16 years of experience in software industry. And apart from that, he have also wrote a book on microservices. Isn't it interesting? So learning from him will be a nice one. He's going to present on a topic like built event-driven architectures effortlessly with AWS. So Karthik, can you please add Lalit to the stream? Hi Lalit, hope you are doing good.
Hey guys, morning, afternoon. How are you guys? Can you hear me?
Yes, Lalit, you are
Okay,
audible.
perfect. All right. So I think let me start on my deck. Uh, all right. Uh, I would be preferably not sharing the camera if I can. Let me figure this out real quick.
Sure thing, Lalit. Like once you start, like we'll put you off the stream.
Yeah, just a second. Where was that setting actually? You are in.
Lalit, I'll handle that from backend, so you don't need to worry about it.
Okay, perfect. So let's start then. So our today's topic is building the event-driven architectures with effortlessly with the AWS. Myself, Lalit, I'm principal engineer, and I'm working in Verizon Connect as principal engineer and working in the role of a solution architect for one of the product, which is related to the field services and telematics. So in Verizon Connect, we do mostly the telematic software, so tracking the vehicles and essentially providing the value-added services along with the tracking of the vehicle and telematic business. You currently we track more than 10 million vehicles across different geographies. We are present in 24 countries, and I'm coming live to you from Dublin, Ireland. So it's 7 o'clock in the morning. So bear with me if my voice sounds little dull. I still didn't had my coffee. Just to refresh my memory, I started when I started this presentation. I was just wondering, like, when I started the AWS use, and it was 2006 actually. All right. As Smile has already told you guys, I have. Well, I should not say the guys. Sorry for that. It's just the folks. But yeah, I prefer more inclusive language. So again, apologies. Yeah, I have written a book on microservices in 2017, which was published by Peck. It was for another cloud provider, but now I'm solely working on the AWS, and I will continue to work on AWS because it just works, right? And for my all community contributions and enthusiasm, AWS has recognized me as community builder, one of the community builder in early stages. All right. Yeah. So we'll touch base upon what is event-driven architecture and what is essentially the serverless application integration services. Obviously, the Lambda comes under it, even the SQS, SNS, and Eventbridge. Filip has already touched based upon it, but we'll go in a deeper section, and we'll also touch base upon the application integration pattern support in the AWS tooling or the services, and we'll go in bit deeper with the AWS Amazon Eventbridge, and we'll also see the use cases. All right. So Smile, if you don't mind, can you put my camera off, please, if it is possible?
It's already off.
Hey Lalit, so your camera is on. You'll have to turn it off from your end, but
Okay.
for
Got
the
it.
viewers, it's complete. Yeah, perfect. That's
All right. Yeah, I mean it's very difficult when, because I use a lot of hand waving when I'm doing the talking, and especially in the COVID situation, since we are not in a physical space, it's very difficult to actually just it's a bit weird, right? All right, so let's go on. So yeah, we touch base upon the agenda, and we'll also see at the end of the session use cases. So there is a lot to cover. So let's move on. All right. So what we are dealing with today? So what is let's revisit the today's systems. All right, as compared to the couple of years ago. So today's systems are we especially on the internet speed. We have the gigabyte of internet speed or bandwidth, and in fact it is going on petabytes as well in some of the special use cases like CERN. Uh, we also have thousands of multi-core servers as compared to whereby in couple of years ago we were running on our servers for just a couple of giant single core servers. We expect, or in fact, everyone expects milliseconds of response time. Nobody wants to see the buffering of YouTube or Netflix. Same expectation is carried over across the different website and the daily usage of the internet users. Then user expects 100% of the uptime. It's very difficult for user if, say, Google is not coming up, or say larger properties like Facebook, Google, or these kind of properties are not coming up. And essentially the data economy has grown like anything, and we are dealing with the data sizes in petabytes and zettabytes. All right, so that's the current landscape. That's what we are living in today, right? So let's see how it actually relates. So in 2013, a group of distributed systems expert gathered around and wrote the first version of a reactive manifesto. So this is the diagram from Reactive Manifesto. So they assembled a white paper and in fact published a website, reactivemanifesto.com, which essentially which essentially shares their experience and the principles around building the distributed systems and cloud applications. While in 2013, the cloud was not precisely what it is today. The dynamic creation of ephemeral resources was already a well-known mechanism. So Reactive Manifesto defines the reactive system in 4 principles: being responsive, being resilient, being elastic, and being message driven. So if you see the picture for the first time, then essentially you maybe find the arrows confusing. It's going around here and there, but essentially it can look like basically it will all make sense once you will see once you will hear the reasoning. So instead of trying to make the distributed system simpler than, so the fundamental principle behind the reactive system is, instead of trying to make the distributed system simpler than they are, reactive system embrace their asynchronous nature. They use the asynchronous message passing to establish the communication between the components. Asynchronous message passing ensures the loose coupling, isolation, and location transparency. In reactive systems, interactions rely on messages sent to the abstract destinations. So these messages carry everything, data as well as failures. Asynchronous message passing also improves the resource utilization. And employing the non-blocking communication also allows the idle resources to consume almost no CPU or memory. Then asynchronous message passing enables the elasticity and resilience as depicted in the two bottom arrows from the figure. All right. So I was talking a lot more about the asynchronous message passing, but trust me and bear with me that it is covered in the next slides. But essentially, so the way to read this diagram or read the reactive systems is, the foundation is message driven architecture or message driven systems, and the characteristics what are propagated in the above is elasticity, resiliency, and responsiveness. So that's the whole meaning of the arrows, and in fact the reactive systems manifesto. So let's move on. So Alan Key, one of the great computer scientists from US, who is well known for his idea around or research around the object-oriented programming, and in fact establishing the object level message passing. So the what he said with respect to the object-oriented programming is also true in terms of a distributed system. So the messaging is the big idea here, and it's the key part for even distributed systems. All right. Then we will see. So this is another quote from Tim Bray, who was a former senior principal engineer from AWS and even the spec author for XML spec. So from his standpoint, he went to even he went further even to Alan Kay, and he's describing like if you are proclaiming that you are having a cloud native system and it's a large scale distributed system. And if you are saying that if it is you are not using any messaging component, or there is no messaging involved into it, or there is no asynchronous processing is involved into it, probably there is something or terribly wrong in the whole system, right? So let's explore the whole communication. So I think this, once we understand this, it will make a lot of sense. The previous reactive manifesto slide will make a lot of sense. So in communication, we have two types of communication: synchronous communication and asynchronous communication. So usually in the settings, when we are doing the in real life examples are video conferencing, when you're talking to your friend or your family members or even your colleague, the expectation on the video conferencing is basically you will respond, or the speaker or narrator will actually respond quickly and promptly. And if it is not you don't respond naturally, there is some, like, people start checking their internet or something wrong in the communication itself, whether the listener is able to listen or not. So that's the simple, plain and simple real life example of synchronous communication. On the other hand, we have asynchronous communication. You can treat it, the real life example is email. So in email, the expectation is not a prompt response. It's just like based upon the whoever is receiving that email, that person needs to based upon his leisure and his time availability, he will respond whenever he wants, right? So same concept is translated into the types of communication in the systems. So when we were talking about previously in the message driven systems, we have two types of communication: synchronous and asynchronous. And maybe I should repeat again. So whenever asynchronous message passing is concerned, basically we are it's a non-blocking communication. So essentially the process which is starting the communication does not wait for the response, and it can continue or carry on its work. So that's the reason it's called non-blocking communication. What also it means is the CPU cycles or a memory is not idle. It can be occupied by the other context which that has happened within the process A, or between that particular CPU. So essentially it's a fully utilization of your resources. All right. So now let's explore what is the kind of messages that we have in our architecture, or event driven architecture, or even the asynchronous communication. So more or less we have two types of messages: the commands and events. When it comes to the command, every system issues the commands. So commands are the action that user wishes to perform. That's the reason it, like, command basically summarizes to I intend to do XYZ. So I intend to create the customer, in our case what is represented on the slide. Basically it in most of the HTTP based APIs are passing the commands. The client asks for action to happen. It is important to understand that action has not happened yet. It is about to happen, or it is going to be happen. It may happen in future, or even it may be rejected by the receiving process or receiving application component, right? So in general, commands are in general the commands are sent for the intention. So it is specifically targeted towards the specific receivers in the system. All right. Then we will see the events. The events are the special type, or essentially it is, some people also refer them as a facts, because they have already happened, right? So the simplest definition of events is something already happened in the system, and there is a side effect which is getting produced, right? So if we basically event can be the result of work done by the command, right? Also, if we go back to our HTTP request example, once the response has been written, it had become an event, we had seen that HTTP request, and it's processed by the system, and it has actually created a response. So that event can be written to the log or broadcasted to the different parties to make sure that all the communication, all the component in the system are aware of that particular fact that has already happened. Another peculiar characteristics of event are actually events are immutable. You can't delete those events because that has already happened. So you can't actually erase your past. So something in that sort, right? And you can't change the past, right? So if you want to refute or previously sent fact, which is like previously sent event, then essentially you need to send the compensating event, right? So yeah, so that's the whole point of event. There is a when we we name the events or even commands, they are named in a certain fashion. So since we have to show the commands futuristic intention, we have to write it into the present tense, whereas event has happened in the past, so it is written in the past tense. All right. So now coming to the whole point, if we understand the asynchronous communication and commands and event, how we can define or interpret the event driven architecture. So this is not a concrete definition from any book or something. It is more of a my definition, and it's a mouthful as well. I'm aware of it. But let's see what it is. So essentially the keywords here are distributed, asynchronous, and integration to create, right? So if you have the highly scalable, you need a highly scalable system and loosely coupled or decoupled reactive system and responsive system, you need to have a event driven architecture. That's the whole meaning of it. And there is a characteristic like it is distributed, it has to be asynchronous, based upon the asynchronous communication, right? And in summary, events drives the data processing. All right. So in normal system where we have a synchronous nature of a systems or component, we essentially the data processing happens based upon the commands. In event driven architecture, the data get processed once you get the events. All right. What are the advantages of the event driven architecture? So let's see this. So basically in the first of all, loose coupling, I think it's kind of a given, but basically event driven architecture decouples helps in decoupling the components, and it helps in the logical separation of a production and consumption of the event. So it creates some sort of a categorization in your system components. Some components which actually produces the event, most of the people call them as the producers also, right? And there are consumers of the event, which is typically consumes the event, right, or processes the event or acts on the event, right? So producers are not concerned with how the events are consumed, whereas the consumers are not worried about the produce, how the events are produced. Essentially the reason is because they are unaware of each other. The reason is basically the whole system is decoupled by certain mechanisms. We'll see those mechanisms in further in the presentation. It naturally, since all those components are not aware of each other and just working on the triggers or the events and reacting to the events, the application scaling, it enhances the whole application scaling. Producers and consumers can also be added or removed based upon the requirements. So you can, like, you have the flexibility of developing the components independently of each other. Same thing happens with the fault tolerance. So even if, say, one of the component goes down, you are not taking the whole system down, which is completely opposite to the certain architectures. Nowadays those are monoliths, but yeah. Better real life user experiences are event driven APIs lead to better interactive experience for the end user with the modern interactivity demands by abstracting many of the responsibilities previously assigned to the users. Of course, this may increase the complexity at the producer level, so it's kind of a simpler at the consumer side, but it may also increases the complexity at the producer side of the components, because they need to make sure that event is actually getting generated and delivered to the consumers, right? So overall complexity may slightly increase in event driven architecture. However, you have the all other benefits along with the business agility. And essentially, you don't need to develop all the producers and consumer at the same speed or even at the same time. So naturally, even you can develop a consumers at certain later stage in the system when the system is already fully developed or it's in the production. There are certain challenges. We talked about some of the complexity challenges. Another mind shift on the developer side is we need to be aware of the eventual consistency and base acid versus base consistency models, right? That's the whole mind shift, and essentially it also implies that our user experience also needs to slightly change to better fit the eventual consistency models. Then observability is another challenge in the event pipeline. However, I would say that in AWS there are certain services which is actually helping the observability of the event pipelines and all of the services that we will see later. All right, but still is in a largely generic speaking of the event driven architecture across the systems, it's still a challenge. Consumers needs to be immutable. That's another quite peculiar characteristics of event driven architectures and the components which are serving as the consumers in them. So you can't have if you receive, there is no guaranteed delivery, so you can actually receive a same event twice. So for that reason, you need to have, like, you just need to recognize that this is the message which I have already received in the past. So essentially it may be a flick in a network or flick of the producer side. So essentially we just need to ignore that. So that kind of immutability we need to have in the consumers. Error handling is again challenging we are thinking about the UX scenarios. Event replay scenarios is really tricky ones, but thanks to AWS services like Eventbridge, which is offering these kind of tricky scenarios of error handling or even event archivals and event replay out of the box. And definitely we'll see this in the next section. So yeah, this is again one of the famous tweet which exhibits the characteristics of a distributed system. So you can't guarantee the exactly once delivery and guaranteed order of the messages. That's what Matthias actually is trying to show, and it became very popular. I think it's the whole it's a very short and sweet summary of a distributed systems and the challenges around it. Yeah, so when we saw this kind of my interpretation of an event driven system, we didn't focus on one of the word, which is integration patterns. So the interesting part of this is it's not new. So Gregor Hoppe and Bob Wolf actually has written the whole book on the enterprise integration patterns, and thanks to these patterns, actually the event driven architecture or defining and designing the event driven architecture becomes pretty simple. So we'll see some of the patterns which is listed here, right? Yeah, so you may say that how these patterns will help, right? So essentially there is no simple answers to if you are working in enterprise settings, you may notice or you may know the data silos as well as the departmental silos. And if we are talking the enterprise to enterprise integration, which is like outside parties or vendors, etc., it's really a complex ecosystem. So whoever is familiar with this space, they will certainly understand and recognize that it's not a piece of or piece of cake or or a easy thing. So in our opinion, actually anyone who claims that integration is easy must be either I mean he might be incredibly smart or incredibly let's say optimistic. And definitely, I mean, even though I mean many vendors claim that it's very like if they offer, they have come up with the offering and which is doing the XYZ, but you need to verify and take that whole marketing buzz with a pinch of salt. Thankfully, AWS actually lives up to the expectations and their services. So I think we are in a sweet spot as the AWS community. Yeah, so the patterns are actually even though, yeah, so let's talk about a bit more about the integration. So even though the integration is a broad and difficult topic, we can always observe basically that certain people are knowledgeable about it because they are building in these kind of a specific type of system for over the years. And because of their experience and maybe their early mistakes and learnings, we have the patterns at our hands, which is depicted here. So before we go to the discussing the patterns about the listed patterns, point to point, pub sub, etc., let's see what is the message channel. So whenever the two applications wish to exchange their data, they have to do it through some pipe. Let's call it as a pipe, as a layman's term, right? So that pipe is called as a channel, which is connecting these two sort of components in the system. So what kind of different things that can happen in this whole space? Like there is a application A and application B, or a component A and component B. You can call it producer, consumer, whatever, and there is a message channel around it, right? So at least there are multiple patterns, but we are just focusing on the messaging patterns. So let's see what is the point to point communication or point to point channel. So when we have to send a message to the point to point channel, this ensures that there is only one receiver, and that will receive the particular message. So point to point channel ensures that only one receiver consumes any message. If the channel has multiple receivers, only one of them can successfully consume a particular message. If multiple receivers try to consume a single message, the channel ensures that only one of them succeeds. So the receiver do not have to coordinate with each other. The channel can still have multiple receivers to consume the multiple messages concurrently, but only single receivers consumes any one message, right? So it's purely a greedy scenario from the consumer perspective. So if the producer is sending the messages, and even if there are multiple consumers, let's say at the other end of the message channel, one of them will always win. Not all of them will win, one of them will win. That's the whole simple point to point communication or point to point channel. Again, this is what we are talking about, is a pattern, right? Then we have the pub sub pattern, which is most of you all are familiar with. It's more or less like a broadcasting of a message or event to the interested parties, right? So if we have to send the event on the, or say message on the public publish and subscribe channel, which delivers the copy of particular event to each receiver, which means it copies internally based upon the number of consumers at the other end, and it actually delivers the copies of the message. So essentially this is another flavor of like all wins at the consumer perspective, right? In this way, each consumer gets the message once and consumes the copies. Once they consume the copies, the message will disappear from the channel. So there the next one is message router. So in message router, what happens is message router differs from the most basically if you it's a plain and simple routing based upon certain characteristics of the message, right? So if we insert a special filter, or let's call it as a message router, which consumes a message from one message channel and republishes it to different message channel depending on the set of conditions. All right. So it's again a specific or subset of a pattern called as a pipes and filters. So here the filter is represented by the message router, right? Some like this is a convoluted space. Some people may say that, oh, it's not the filter is not a router, or router is not a filter. It again based upon your interpretation, but the pattern is very clear that message router basically it connects to the multiple output channel, and thanks to the pipes and filter architecture, the components surrounding the message router are completely unaware of the existence of the message router. A key property of a message router is that it does not modify the message content. All right, it only concerns itself with the destination of the message. Now the last one, which is again more interesting, so event bus. So let's say the question is, what is the architecture that enables the separate applications to work together, right? But in decoupled fashion. What it means is consumers should not know about the publishers, and publishers should not be aware of the consumers. So what is that the pattern of message channels or messaging? So that's the pattern is called event bus or message bus. And the message bus is a combination of a data model, as like it has a three components into it in this pattern. Bear with me. Unfortunately, I don't have the diagrams, but I think let's bear with me, right? So common data model, then there is a common command set, and there is a messaging infrastructure. So there are three components which constitutes the event bus or message bus. All right. So these three components, the data model defines the eventing or messaging characteristics or the schema for the message. Then common command set actually either basically carries out the message, and messaging infrastructure is just the to carry out, or you can again say it's a pipe essentially. This is now if it sounds too complicated, that event bus is sounding too complicated, just forget about it. You can put an analogy of a computer system where you have a certain pieces like CPU, memory, and peripherals, and essentially your serial cable or the bus in the CPU bus is actually communicating with all these three different parties, right? So that's the analogy of an event bus. Again, the event bus carries a different messages, and based upon it also the whole architecture or this pattern communicates the different systems or components. All right, so let's move on. So now we understand some of the or bits and pieces. I know it may sound, some of when I was describing this pattern, some might sound boring. However, that's my fault. Maybe probably I need to add the diagrams. But essentially, these patterns will be more fruitful when we go to the AWS side of the things, and you will recall these patterns when we see them, right, in the services, AWS services. So event-driven architectures with AWS serverless. So again, the serverless, the most prominent characteristics of the serverless is you just write the business logic, and AWS or your cloud provider will do actually the heavy lifting. You don't need to, you just need to pay as you go. You don't need to operate the servers, even though that's just the responsibility of your cloud provider. In our case, it's AWS responsibility. And that, so we as a value providers, we just focus on our end customer delivery and end customer generating the end customer value, right? So all the code, I think this is one of the famous statement from Werner Vogel, the CTO of AWS, that all the code you ever write is business logic. That's pretty much defines the serverless. And yeah, I mean, without Lambda services, which came in 2014, which is like way ahead of its time, serverless story cannot be complete, be it any presentation or be it any book essentially on the serverless, right? So let's see, we are not going to talk in deep for each and every part of the Lambda, but if you see that we have Lambda has a 3 execution models. So synchronous, asynchronous, and stream based. They are also named as a push, event, and poll, right? So in synchronous model, we have the API. So your request hits to the, let's say, order endpoint, and that request itself triggers the AWS Lambda function, right? So it's a kind of a normal, but it's actually a push. And once you receive the request, or the Lambda processes that request, the expectation is it will be synchronously delivered. The response will be synchronously delivered. All right. In asynchronous model, the Lambda gets triggered by the event. One of the event, it may be from SNS or S3 or any other Lambda trigger service on AWS cloud, and you get essentially the number of requests, and like once the Lambda executes it, you can have a response back as a callback. In the poll-based model, typically it happens with the Kinesis stream or even AWS DynamoDB, and you get a whole stream of events or messages, and those get buffered or internal. There is an internal queue which is maintained by the Lambda. And once you can either process the whole batch as well, or you can process one by one based upon what are the configuration that you have set. But that's the whole model of poll. So essentially, once it finishes, the queue is empty, it polls for the next batch of events from whatever the trigger, again, from Kinesis or DynamoDB. So those are the execution models. So now if we go back to our presentation, we might see that the synchronous communication and asynchronous communication. And funnily enough, the model you are choosing, like synchronous or asynchronous, your cost or even the execution or processing time may vary. All right, and there are implications on the whole architecture. If you're whenever you are defining the Lambda in your architecture, you have to define you need to pick the right execution model for your need or use case, right? But in all the scenarios, if you have noticed, the whole thing is actually transformed into the event, right? Then we have not recently, but I think it's last year, AWS Lambda has launched this particular feature called Lambda Destinations. So this is another interesting feature of Lambda, where you can actually pipe through your result of the Lambda to the next service, and you can do the Lambda chaining or even the different services chaining in AWS. So in this case, the Lambda, in our case, we have the Lambda named as the event destinations. So on case of success and failure, so the event is defined, and once you receive the result, based upon that result content, whether it is successful result or it is the failure result, either of the whatever you have configured. Let's say we have configured the SNS like success. If the execution or the result of the Lambda is success, then the result should be passed on to SNS. Otherwise, if it is failure, then our error lambda or something needs to be invoked. So that kind of a configuration you can do. So this is another part of the event processing model which is supported by the AWS Lambda destinations. What are the another set of AWS serverless application integration services? Again, we are all talking about the integration. So if you remember, let me go back. We said this particular word integration patterns is important for us, and we can see that it is reflecting in some of the services that we are seeing specifically, which falls under the category of application integration services. All right, so if you are drawing the diagrams with any of the drawing software, draw.io, Visio, or whatever, or even if you see the standard deck of AWS icon set, you will see the categorization of these services under the application integration services, right? So all we are dealing with the cases of the integration, right? And what we are saying is, to solve that integration problems, we are going to use the event driven architecture. So that is the reason whenever AWS has built those services, those are supporting the eventing systems or events, right? So in terms of API, we just saw that you can put a normal HTTP request and we can go it. So Amazon API Gateway actually supports the AWS it supports the RESTful endpoint and HTTP endpoint. GraphQL APIs are supported by AWS AppSync, but again, these are all triggered by the events. Eventbridge, we'll go in the details. Amazon Simple SNS, again, this is another kind of service which supports the pub sub model or pub sub pattern, right? So now maybe the boring patterns now trying to make sense. So you have seen that there is a pub sub pattern, right? So in pub sub pattern, we can see that there are a broadcast of the messages happens, right? So SNS does the exact same thing, and it's a unidirectional. So you can't have the like both bidirectional. That's the reason they come up with the event bridge, right? Then there is a point-to-point communication which is reflected and supported. That pattern is supported by the simple SQS or simple queue service. For stateful applications or work supporting the workflows, we have the step functions here. All right, which also does the orchestration. So once we have gone through, like we have visited Lambda, we have seen some of the application integration services. So how we should select the service for our designated use case. So the selection criteria is pretty standard one. I would say, like, you have to go for the scale, like check the scale of your service, your requirement for that scale and concurrency, durability and persistence, right? And then consumption, retries or failure models, how that particular service deals with the failures, whether it's supported by the retries or not. And then at the end, definitely the pricing is important for the businesses. Again, we go in a slightly sort of it's not a comparison, but I'm just trying to show through this slide, like what are the different patterns that are supported and why it is different. Because many times people ask this question, like, can I use how should I define, like where should I use the SQS, or should I use SNS or Eventbridge? It's all confusing, but it's not really. So in case of SQS, it's a durable and scalable buffer, and it has the buffer and batching support, and it also has the comprehensive security attached to it. I think its security is given for each and every service, but it supports the messaging pattern of point-to-point communication, right? In case of SNS, it supports it actually has the delivery endpoints like SMS, HTTPS, or any push notifications also. And it is meant for special pattern, implementing the special pattern called as a fan out, or you can say broadcasting to the any of these delivery channels, and it is a pub sub pattern, right? Then there is a Eventbridge, which we are going to see some in some details. So serverless event, it's a serverless event bus, right? So it carries out the events for AWS services. The interesting part is it's not AWS services is fine. Like that's the traditional definition of event bus. Like you have the system in and your own components, and you can have an event bus within your components, which are typically SOA kind of a services. Event buses are there. But the beauty of Eventbridge is why it is called bridge, because it's another pattern as well. So you can have not only it supports your own like AWS services, but it also supports your own application as well as the third-party vendors like Zendesk, Stripe, or any other vendors, right? And it implements the event bus pattern, right? We talked about like selecting the services should also be one of the criteria, should also be failures and retries. So these are the some of the characteristics of SQS, SNS, and Eventbridge, right? So you can see the retry time up to max up to the 14 days in SQS buffer. So you can have it. That's the same thing on the SNS is 23 days. Yeah. And you can retry up to 24 hours with in case of Eventbridge, right? There is also a different support. So yes, in SQS failures are handled by redrive policies. In case of SNS, you have the retry policies, and in case of Eventbridge, you have the event retention and or even event retention or event archival and replay policies. All needs to implement the dead letter queue pattern for handling the failures, right? So this will also help you to basically choose the service as per your scenarios, as per your use case, right? Uh, let's go for Eventbridge. So Eventbridge is fairly recent service as compared to the SQS or SNS, and it is serverless, so you don't need to operate any servers or any operational infrastructure is there. It's a pay as you go, and the beauty of it is it supports the AWS services, 90 plus services, 17 plus services as the targets. Then it also supports the third party vendors, and 1 million events put into the single bus will be free of cost, or constitute the free tier, right? One thing which I definitely like in a complex enterprise organization settings is cross account and cross region support. So cross region support is recently launched, and it's a fantastic. So essentially, because SQS and SNS, if I'm not wrong, they are regional services. The Eventbridge is the one which actually can carry the things across the accounts, not only across the accounts but even across the regions. So let's see the Eventbridge. The architecture is pretty simple. It's not just a standard. So one thing to notice is, as I said, it's not just event bus. It has the AWS or Amazon Smart Guys has added some of the elements which really make this service worth to notice and even interesting, like schema registry, code binding, and schema discovery as well. We'll see what it means. So you have the sources, which is like your event sources, what services we have seen 70 plus services as the sources. Then event source, then you have certain kind of event buses. So each supporting each kind of a bus. Like for default is supporting the AWS services, custom is supported by your custom applications, and partner event bus supports the partner application or carrying the partner events essentially, right? Out of the box, it supports the events archival and replay for audit purpose, or if you have some certain logical bug or anything happens in defining your schema of the events, etc. Trust me, this scenario is really difficult if you try to implement manually or on your own. And this is coming out of the box. Like sometimes people does not recognize the brilliance of AWS services or engineers, basically what they are offering out of the box. So that's one. Rules are the certain conditions and the elements on which basis the event routing happens. and at the end of the pipe, basically you have the destinations, or essentially the targets. Not only that, these targets is pretty simple, like the target services or target applications. There is a schema discovery and schema registry, which is a fantastic element. So imagine a scenario where you are working in a large setting. You have 50 teams in your organization, and everybody has owning the microservice or some sort of a component which is emitting the event. So it will be a chaotic a scenario where you will not be able to find it out manually, like what's happening, who's presenting which event, what is the structure of the event, and all that sort, right? So to settle that down, Eventbridge smartly provides the schema discovery. So even if, say, new event goes through the one of the bus, it identifies that schema, and it actually can you can also register the it into the schema registry, which is a discoverable way for finding out the schemas of the events. Even if you change your existing event, the new version it will be automatically published. I think there is some restriction, but essentially automatically publish of the new event will happen, and that will be also available in your schema registry, so that whenever you are working with, say, other teams or collaborating with the other teams, you can't say that, oh, I didn't send that email, so the other team will not know, or they will be got caught by a surprise. So that kind of things is like brings a lot of value, at least in a space of enterprise, right? When you have a geo distributed team or multiple teams working. And not only that, if you are working with, say, Visual Studio Code or JetBrains or that kind of IDEs, and any of the languages like Python, Go, Rust, you can have your code bindings and libraries available to you. So your event client will be automatically generated. All right. Let's touch base upon the rules. So let's say this is the example event. We'll go into that schema. So essentially, Eventbridge and even SQS and SNS supports the JSON-based schema. So you can have a JSON schema where you say, let's say there is a property called source. So you can define this rule set based upon the source characteristic. Not only that, you can actually even go in a detail level, and you can set up some sort of operators and rules. So it's called content filtering, and you can also filter your content. And while doing that, the content filtering, the Eventbridge does not alter in any way the data of the event or the envelope of the event. All right. Yeah, so we talked about the schema registry and discovery, so I'll not spend a lot of time here. This is another fantastic feature of Eventbridge, which is very hard to implement if you want to go for your own. So in this case, the event is getting archived. There is there is an archival store, and you can also retry or replay the event. So generally, like whenever you have the replay, you can get specific characteristics. You can modify that content of the event, or it will be automatically modified to represent that it is essentially a replay. You can also do like even more advanced filtering scenarios, like you don't, like when you're replaying, if you want, say, let's say in original setting you are sending it to the event bus XYZ, right? In case of replay, you can actually, or advanced replays, you can actually also send it to some other bus, so that you can do the testing of the events, etc., etc. So even the testing becomes way easier of the event driven architecture in the event driven architectures, with the help of Eventbridge and the replay functionality. So your test can actually take the events from the production. Obviously those the PI and etc. data should be masked, but rest of the things can be replayed and used in the lower environment for your testing features. Even if even if you don't need a replay, you can still work with the archive for compliance reasons or auditing purposes, right? When we are talking about all the good points, I think you also need to understand when you should not use the Eventbridge. So basically, whenever Eventbridge does not guarantee the ordering of the event. So whenever you require the ordering guarantees, you need to combine the different services. So you can use the SQS FIFO and even SNS FIFO topics, and you can actually compose it along with the Eventbridge, but does not mean that Eventbridge will guarantee the ordering of the messages or the events, right? Even do deduplication, if that is your requirement, or push delivery, you have to push something to certain places. Probably Eventbridge is not the case. Same thing for ultra low latency. Unfortunately, this is one of the requirement. At least I wish that Eventbridge team can solve it in near future. Right now, the event, if I'm not wrong, the latency for SNS and SQS is 25 milliseconds in within the account. But for a Amazon Eventbridge, it can go up to 560 milliseconds. Again, those are approximate. You can figure out the numbers from the AWS documentation. But yeah, that's not a ultra low latency solution or service, right? And also, naturally, I think it applies to all the services. But I just mentioned that if you are looking for some protobuf or other kind of a wire formats, then probably Eventbridge is not for you. Again, you can do some sort of hacks, like you can develop your own envelope, etc., and still do that, but that's not the ideal way. One more tip is, now you must be wondering that how we should develop the events. So in case of event modeling, there is actually the recent development has happened in an open source space or within the CNCF serverless group, and they have come up with the cloud events, which is recently go into 1.1 version, which is like a publicly available, and you can use it in production. So it is what it is. So basically it's a specification. And what it gives is you have the structured event schema. Based upon the structured event schema, you can do a lot of things, and even if your event is not there, based upon the convention and the structure of the event and the semantic meaning of that particular schema elements, you can define the you can still meet your future needs, etc. So and yeah, there are language SDKs or language bindings already available. The beauty of it is, AWS or most of the public cloud providers, AWS, GCP, Azure, whatever the events they are emitting, they are compliant to the cloud event specification. So whatever the event you are seeing, S3 object created event or SNS event or other things, they are compliant to the cloud event. So if you are developing your own application, custom applications for, and you're going with the event driven architecture, please try to define your schemas with the cloud events. All right. Then in my title of a slide, I said like effortlessly, right? So even building the event driven architecture effortlessly with AWS. So now with the some of the features of Event Bridge, you might have seen that what kind of a complex scenarios can be become out of the box for Eventbridge or AWS services, more or less, right? On top of it, if you are in a space like, or if you are wondering like how we should actually plug this all and stitch this all and do this, we don't have the time, etc. There are some fantastic guys in open source space, as well as in from the AWS team, who are working on the serverless LAN and CDK patterns. So you can use actually the CDK patterns which are available specifically with AWS SAM CLI as well as the AWS CDK. There are 70 plus templates at least on the serverless LAN, and there are a couple more on CDK patterns. So there is no excuse not to basically go for the event-driven architecture, provided the support of infrastructure as a code, right? Yeah, and you can copy it, you can even develop your own, you can have your you can contribute to these repositories also. This is another use case of Eventbridge in real life. So there is a company called CloudStrike, which are actually working in a security space. So what like this case is similar to their own solution. So it's a real-time threat mitigation. So There are a couple of services like CloudTrail, CloudWatch, using GuardWatch and Inspector. You can actually identify or detect the threat, and there is an event emitted, and you can reroute it to the one of their services, and you can actually even take, like, it is Eventbridge also supports the cloud deployment services or AWS deployment services, right? The code pipelines, etc. So you can actually correct your security posture on WAF or other spaces. So it's like one of the use case which is really fantastic. Another use case I would like to show is how these all things are coming in a play. SQS, SNS, the patterns, right? So this is again the sort of a disclaimer. This is the example of loan broker, which is a famous example on enterprise integration patterns website, which is maintained by Gregor Hoppe. So and in India, you can see Loan Bazaar, Bank Bazaar, that kind of a loan brokers are available on internet or online, and they provide these kind of services. So the business of a loan broker is pretty simple. It has to take a quotes from different banks and has to provide it on to the customer, right? So yeah, receive the customer's quote request, then obtain the credit score and history from the credit agency. Based upon these kind of rules and certain in-house rules, determine the most appropriate banks to contact, send that request to each selected bank, then collect the responses from each bank and determine the best response, and pass the result back to the consumer, right? So that's the more or less the use case and the flow that we need to architect, right, or provide a solution for. So again, this same diagram is just taken from the enterprise integration, but it is beautifully depict what we were talking about so far in the whole presentation, right? So you can see the AWS services, which is mingled really nicely with the PubSub pattern. So if you start the flow, so whenever customer sends the quote request, it receives or it triggers the SNS. It triggers the flow for the token, as well as it triggers the mortgage quote request. The fan out happens and it goes to the different destination banks. The destination bank has been actually the API has been executed through the Lambdas, and this Lambda then these banks APIs will actually collate the result, and essentially it's an event bridge. So it like Lambda result can be actually piped in for event bridge, and that quote request or quote responses, right, or quotes itself, right? So the quotes are routed based upon the queue which is attached to the default buses, and those queues or those quotes are flowing through the mortgage quotes are flowing through the again Lambda service, which is a quote aggregator service, and then stored into the mortgage quotes DynamoDB, right? If it is timed out, then again the invocation happens by the quote aggregator service, and the token is passed. So time token is passed, and actually then you can also get aggregated. So that's how the list of quotes is represented on the customer. If customer wants the email, etc., again we can plug the SNS and then we can send it across. But all our patterns and like PubSub pattern, message event bus pattern, or message bus pattern, point-to-point communication, all these things along with the AWS serverless services are coming together and forming this solution. So I think that's the best part of I think that's the best slide to end this presentation. Sorry, we are out of time, but yeah, just to provide the summary. The last point I'll not read through all these things, but essentially if you realize, even the AWS serverless services has been developed based upon the event driven architectures, right? If you notice, so please explore this space more, and if you try it out, or if you have the use cases, try to use Eventbridge SQS SNS. We also saw what are the selection criteria for these services when you should choose SQS SNS, and what are the different criteria, right? And we also saw the templates which is available with the SAM CDK as well as SAM CLI as well as the CDK patterns. With that, I think if I have attached the further reading section, I will share the slide decks shortly. Probably, if you follow me, I will also contact the organizers so that you can get it. But yeah, you can explore this space with this further reading these papers as well as some of the blog posts. If you have any questions and queries, feel free to contact me on my LinkedIn, or you can also ask here. I'll be here for another 5 minutes. And yeah, thank you.
Hey Lalit, thank you so much for an amazing and insightful session. I barely knew about event-driven architecture before
Right.
the start of the session, and now I know a lot about it. So yeah, thank you. So guys,
Yes.
if you have any questions with respect to the session, please post them in the chat section, and we'll happy to answer them. Before let people add the questions, I have one
Mhm.
question for you. So what fascinated you to go in exploring event driven architecture or microservices? So how did you went in that field?
Well, I was like couple of years ago, at least 6 years ago, I started to work in a fintech company named Synchron, and where we were doing the all the event-driven architectures or the messaging patterns, etc., in the old-fashioned way with the TIBCO buses, etc. So and we were defining the solutions. I mean, there is no other way when you have to go at the scale of a London Stock Exchange or New York Stock Exchange, and build the system for the banks. You don't have any other way. So the reason is you have to support the low latency solutions. And there I have seen the and actually taken the pain and pain of going through all these kind of patterns, and even actually applying some of the patterns, and saw firsthand, like if we have to do it on ourselves, how difficult it is. Even though there was some bits and pieces support from the existing, like that time, legacy vendors, right? And now, coming back to the flashback, like then we have the I work in the Dell, again as on their Dell.com solution, where we have the 1 billion page views per day, that kind of a scale. So again, that's there is almost like no other solution which can you can define that kind of a requirements, or you can cater to that kind of a load and scale with any other architecture. Microservices was I didn't know that when it started with around, I think it started with SOA. Meanwhile, we don't, before the microservices, we have the SOA, and people were trying to call it something else, as well as when they were chopping out the services in granular fashion, as compared to the core services what we have in the SOA. And yeah, that's the time when it catch my attention in some of the email list and the user groups. And yeah, then Sam Newman came up with the book, and I think rest of the things, that's the time, like everybody uh, got like so the patterns were there, or architect microservices architecture was there, but nobody was calling it as a microservices, and that really was the apt name for the whole paradigm and mind shift across the industry. So yeah, I got fortunately involved in writing the book around it, because I was working with the Dell at that scale. So one thing led to another, and it becomes a book.
That's interesting. So
Thank you.
we have few questions in the chat
Mhm.
section. So I'll show it up. So our first question is from Srishit. So, so he asks how to handle idempotency and failures in event slash
Yeah.
async slash event driven architectures.
I think that's a great question for idempotency. There is I'll explain, but because we are running out of the time, I think there is a blog post by James Beswick on AWS blog where essentially he talks about the specifically idempotency and failures. For failures, there are standard patterns like dead letter queue, which is again a pattern that you need to configure for any of your services, which is triggered by the events, right? For idempotency, there is always, like for example in SNS you have the message ID and there is certain kind of identifiers which you have to keep a record, and you need to identify like, oh, did that particular like when you're taking the processing of the event, you need to check the previous instances whether that ID has been already occurred or not. uh, and that's how you can then just discard it. But there is a whole blog post around the same topic where James has explained the SNS, SQS, and if I'm not wrong, even other services are there. I have attached that blog post some sort in my presentation for the reading section. I think I was kind of expecting this question, so I did that. Thanks.
So we have one more question again from Strashit.
Sure.
So he asks, what are the some real world use cases for archive reply
Oh,
scenarios?
it's very simple. The real world use case for archive and replay is for replay. In case of replay, if you think about a situation where you have all the good architecture, etc., but when you are processing the event and there is a downstream, you are generating another downstream event, and you have a logical bug in your code, right? So all your event which is generated for the downstream system has to be corrected, so that the whole system is get rectified, right? So in that kind of a cases, you have to have a replay scenarios or a replay of the events. On archival, the needs are more or less compliance or auditing. Another nowadays I am seeing that the data science and ML applications on the whole event archival store or repository. I would prefer to call it as event archival rather than event source, because event source is completely different. We are not treating this event archival as a source of truth, or we are not having that traditional projections and CQRS and all these things. That's more of a system design level pattern, and event driven architecture is a more of a architecture level pattern, top level pattern, right? Hope that answers your question, Shushit.
I guess it did. So,
All
yeah.
right.
Thank you so much, Lalit. That were pretty much questions we have. So,
Cool.
thank you so much for sparing your time on a Saturday morning.
Thank you so much. Thank you for the audience being patient with my explanation. Sometimes the patterns, etc., seems boring, but when it comes to the fruitful meaning at the later stages, I hope it has made the session whole interesting. If you have any feedback or any further questions, feel free to connect with me. I'll be definitely sharing the deck on my LinkedIn and other social media, as well as the AWS Serverless Saturday team is enthusiastic enough, and hopefully they will also share the same. Thanks to you as well. Smile.
Yeah. Thank
Cheers.
you, Lalit.
Bye.
Have
Happy
a nice
Saturday.
day.
Bye.
Yeah. Bye. So I before we wind up, I have a couple of announcements for the people who have joined late. So let me flashback all the announcements which I have made earlier before starting the session. So let me quickly share my screen. Okay, I hope my screen is visible, so I'll present it quickly. So this was Lalit with us, who described and who beautifully taught us how to build event-driven architectures effortlessly with AWS. So last but not the least, let me repeat couple of announcements. So as you all know that AWS Community Day South Asia edition is coming up. It is coming on 22nd and 23rd October this year. They have planned and prepared they have connected with amazing speakers for the session for the AWS Community Day. So if you have not registered till now, do register it for some amazing sessions. And last but not the least, we have our GitHub repo available, in which we share all our updates, all our if we talk about all the presentations, all the speaker decks, and what else we have for next upcoming sessions are added on this GitHub link. Do visit it and check it out. And if you have any requests of what the next session should be, do let us know on the in the mentioned GitHub. In the GitHub, there are some email IDs mentioned. Do shoot a mail to them, and we'll happy to arrange sessions on the particular topic. So yeah, that was pretty much from my side and Team Serverless Saturdays. Thank you all for joining on a Saturday morning and spending Saturday with us, learning amazing things about serverless. We'll connect next month with amazing speakers. Thank you.